Hi, Mr. Shivendra Acharya, HOD Physics, U.V.K College, Karama. I have to try to concept you online classes of physics. To the first part, students, second paper of physics, the first chapter, heat. First question raises is the transport phenomena of molecules in a gas. Gases are made of particles, molecules. According to kinetic theory, the molecules of a gas moving with a large velocity, even at normal temperature, ordinary temperature, they frequently collide with one another. When the speeds of direction changes, since the molecules exert no force on one another, exerts during only on the period of collision. They frequently collide, and exertions of forces except during collision may not hold. They move in a straight line. A straight line, we can state it in this way, that constant speeds between successive collisions, they move in a straight line. Thus, the path of a single molecule in a series a sort of zigzag path of different lengths. The path of different lengths are called the free path. The mean free path is defined is the average distance between traveled by molecules between two successive collisions. We start to explain the question's answer. A term also may be explained before. This is the finite diameter of molecules. May it be that molecules are not spherical. Then meaning of the molecule diameter will be different. The molecules of a gas do not fly freely from one place to another place. In the container, they collide frequently. These molecular collisions cause molecule to move in irregular zigzag path. Irregular means the time period taken by it, the movement taken by it is not same. Molecules so collide mutually leads to conclusion that they have a finite size, finite geometrical size. In monoatomic gases, the molecules behave nearly as rigid spheres, whereas in other gases, the molecules have two or more atoms. In such type of molecular structure, while moving in the gas, one another comes near to the another, near to the another molecules. In such position, their centers are separated by a diameter. And separated by a distance, we can say it molecular diameter. In such position, intermolecular forces between them react to such an extent that are said to have been in collision. Now, we have to start the first question raised by, we have stated as transport phenomena of gases, transport phenomena in gases. According to kinetic theory, the molecules of a gas move constantly with various speed in all directions. If in a gas the mass velocity, temperature and molecular concentration varies from one part of the gas to another parts of the gas, then moving molecules transport respectively the momentum, kinetic energy or mass from one part to another in order to bring equalization throughout the gas. This gives us a rise of viscosity, a rise of conductions and diffusions. We can explain as first point the different parts of the gas. may have different velocities? If so, there will be a relative motion. The relative motions of the layers of the gas with respect to one another. In such cases, the layer moving faster impart momentum to slower motion. Slower moving layers to bring the equalization we have stated before, to get the equilibrium state. This gives a rise in the phenomena of viscosity. The different parts of the gas may have different temperatures. If so, the molecules of the gas will carry kinetic energy from regions to higher temperature to the regions of lower temperature to bring the equilibrium state. This gives rise to the phenomena of secondly we have stated conduction. Now we have to state the third, diffusion. The different parts of the gas may have different molecular concentrations. I suppose that the number of molecules per unit volume. If so, the molecules of the gas will carry mass from regions of higher concentrations to those of lower concentrations to bring the equilibrium state. This gives us rise to the phenomenon of diffusion. Thus we see that viscosity, conduction and diffusion. Conduction and diffusion represent the transport of momentum, energy and mass respectively. This phenomenon, viscosity, conduction and diffusion, are called transport phenomena. Now, the transport phenomenon in gases get ends and the transport momentum in term of viscosity and so on may be stated in another classes of honors second.